Have you ever pondered the existence of hidden dimensions in our universe? This thought-provoking question has been the subject of many a late-night philosophical debate, but it wasn't until the last century that science started to seriously consider the possibility. The concept of hidden dimensions is not a new one. The idea has been around for centuries, nestled within the pages of science fiction novels and whispered in the halls of academia. However, it was only in the early 20th century, with the advent of quantum mechanics and Einstein's theory of relativity, that the notion of hidden dimensions began to take a more concrete form. But what exactly are these hidden dimensions? Well, to put it simply, they are dimensions that we can't perceive or interact with directly. They exist beyond the three spatial dimensions of length, width, and height that we're familiar with, and the fourth dimension of time. These hidden dimensions are proposed to exist in theories such as string theory and M-theory, which we will explore in more depth later on. These theoretical frameworks suggest that our universe may be far more complex and interesting than we could ever have imagined. They propose that there could be as many as 10 or 11 dimensions, most of which are hidden from our perception. These extra dimensions could be compactified or hidden away, so small that they are impossible to detect with our current technology. Or they could be large and expansive, but exist in a way that we simply can't interact with or perceive directly. But why should we care about these hidden dimensions? Well, if they do exist, they could help to answer some of the biggest questions in physics. They could provide the key to unifying the seemingly incompatible theories of quantum mechanics and general relativity, and could even help us to understand the fundamental nature of the universe itself. As we delve deeper into this mystery, we find that our understanding of dimensions has undergone a fascinating evolution. From the early Greeks, who believed in a simple three-dimensional world, to the complex multi-dimensional theories of today, the concept of dimensions has always been at the heart of our quest to understand the universe. So, buckle up and get ready for a journey into the enigma of hidden dimensions. It's going to be a wild ride. To explore hidden dimensions first, we need to understand what dimensions are in the realm of physics. In physics, dimensions are fundamental aspects of reality that help us describe the universe around us. They are like coordinates in a map, providing a framework to pinpoint any location. Now, let's start with something familiar. Imagine a straight line. This represents a single dimension, length. You can move forward or backward along this line. Now add another line perpendicular to the first one. You've now introduced a second dimension, width. You can move left or right as well as forward or backward. Picture these two lines on a flat surface like a piece of paper. But reality isn't flat, is it? So let's add a third line sticking straight out from the paper. This represents height, our third dimension. Now you can move up or down, left or right, forward or backward. These three dimensions, length, width, and height, form the spatial dimensions we're familiar with. They shape the physical space we live in, the space we can touch, see, and feel. But these aren't the only dimensions at play. There's a fourth dimension that's just as critical, albeit a bit more abstract: time. Time is a temporal dimension, allowing us to sequence events, to move from the past, through the present, and into the future. Together, these four dimensions, three of space and one of time, form the fabric of our reality, a concept we call space-time. But physics, especially theoretical physics, doesn't stop there. What if I told you there might be more dimensions, dimensions we can't see or touch? These are the so-called hidden dimensions, a fascinating concept that we'll delve into as we continue our journey. With this understanding, we now venture into the realm of theoretical physics, where dimensions take on new meanings. Enter the world of string theory, a framework that suggests the existence of extra dimensions. Now, this isn't your average physics theory. It's a bold, audacious idea that dares to redefine our understanding of the universe. String theory proposes a fascinating concept. It posits that the fundamental building blocks of the universe aren't particles like electrons or quarks, but rather tiny, vibrating strings of energy. These strings vibrate at different frequencies, and it's these frequencies that give rise to the particles we know and love. But here's where it gets really interesting. In order for string theory to work mathematically, it requires more than our familiar 3 dimensions of space and 1 of time. It actually needs 10 dimensions. That's right, 10. 6 more than we're used to. Now you might be wondering, if there are these extra dimensions, why can't we see or experience them? Well, string theorists have a clever response. They suggest these extra dimensions are compactified or curled up so small that they're beyond our current means of detection. But why stop at just 10 dimensions? Some versions of string theory, such as M theory, propose up to 11 dimensions. String theory is enticing because it attempts to marry two of the great pillars of modern physics: quantum mechanics, which describes the universe on the smallest scales, and general relativity, which describes the universe on the largest scales. It's a grand vision, a potential theory of everything, one that could explain all the physical phenomena of the universe. But it's important to remember that despite its elegance and theoretical beauty, string theory is still a work in progress. Nevertheless, the idea of extra dimensions is a radical departure from our everyday experience. It's a bold leap into the unknown, one that could potentially offer a new perspective on the universe and our place within it. String theory opens up a new perspective, one that challenges our understanding of the universe. So as we continue to delve into the mysteries of the cosmos, let's keep our minds open to the tantalizing possibilities that string theory presents. Who knows, we might just stumble upon a whole new dimension of understanding. The Kaluza-Klein theory takes us a step further, proposing extra dimensions in addition to the familiar ones. This theory, named after the physicists Theodore Kaluza and Oscar Klein, was introduced in the early 20th century. It was a bold attempt to unify the forces of gravity, governed by Einstein's theory of general relativity and electromagnetism, described by Maxwell's equations. Kaluza-Klein theory proposed a 5-dimensional universe, with the 5th dimension being so compact and small that it's virtually undetectable. This is where the idea of hidden or compactified dimensions comes into play. Imagine you're looking at a long, thin straw from far away. From your perspective, it appears as a one-dimensional line. But if you could get closer, you would see that it also has a second, circular dimension. However, this dimension is so tiny, so compact, that from your initial viewpoint, it's practically invisible. This is how Kaluza-Klein theory envisions the extra dimensions. They're not necessarily large and expansive, like the 3 spatial dimensions we're familiar with. Instead, they can be incredibly small, compact, and hidden from our perception. So you might be thinking, if these dimensions are so tiny and hidden, do they really matter? According to the Kaluza-Klein theory, they absolutely do. These hidden dimensions could be integral to the fundamental workings of our universe, influencing the behavior of quantum particles and the forces that govern them. The Kaluza-Klein theory was a revolutionary idea that opened the door for later theories like string theory, which we'll explore in the next scene. Despite its importance, the Kaluza-Klein theory is not without its challenges. It's a complex concept that requires a deep understanding of both mathematics and physics, and it's still a topic of ongoing research and discussion among scientists. But perhaps the most intriguing aspect of the Kaluza-Klein theory is the idea that our universe might be far more complex and multidimensional than our everyday experiences suggest. These additional dimensions, while invisible to us, could be integral to the fabric of our universe. Are there any signs that hint at the existence of these hidden dimensions, you might ask? A question that has been at the forefront of many scientific investigations. While no direct evidence of hidden dimensions has been unearthed as of yet, there are clues that suggest their existence. In the world of particle physics, certain anomalies have been observed that cannot be explained by our current understanding of the universe. For instance, the behavior of neutrinos, tiny subatomic particles, has long puzzled scientists. They're notorious for their ability to switch between 3 different types, a phenomenon known as neutrino oscillation. Some theorists propose that this behavior could be a result of these particles dipping in and out of hidden dimensions. In astrophysics too, we encounter enigmas that could potentially be explained by the existence of extra dimensions. Dark matter, for one, is a form of matter that we can't see directly, but we know it's there because of the gravitational effects it has on galaxies. Could it be that dark matter is actually in another dimension, only interacting with ours through gravity? Furthermore, there's the mystery of the universe's accelerated expansion. Einstein's theory of general relativity explains gravity and the large-scale structure of the universe. However, it does not account for the observed acceleration in the universe's expansion. Some scientists hypothesize that this acceleration could be the influence of extra dimensions. Ongoing experiments and research are striving to uncover more about these hidden dimensions. For example, at the Large Hadron Collider, the world's largest and most powerful particle accelerator, Physicists are looking for signs of extra dimensions. They're doing this by examining the energy and momentum of particles after collisions. While the evidence is not definitive, it certainly stirs curiosity and fuels further research. The search for hidden dimensions is like trying to find a needle in a cosmic haystack. But, if successful, it could revolutionize our understanding of the universe and perhaps even answer some of the most profound questions in physics. In the world of string theory, there's an intriguing concept known as brane worlds. This idea takes us deep into the labyrinth of theoretical physics, where the familiar contours of our three-dimensional reality start to unravel. Imagine our universe as a sheet, a three-dimensional brain, if you will, suspended in a higher dimensional space. This concept challenges our conventional understanding of the universe. We are no longer just inhabitants of three dimensions confined within walls of time, but residents of a brain embedded in a multi-dimensional cosmos. This perspective is akin to imagining ourselves as two-dimensional beings living on the surface of a sheet of paper, oblivious to the third dimension stretching above and below us. Now extend this analogy to our three-dimensional world, with hidden dimensions lurking just beyond our perception. The concept of brane worlds is a natural extension of string theory, which posits that fundamental particles are not zero-dimensional points but one-dimensional strings. These strings vibrate and their vibrations give rise to the particles and forces we observe. Now, if strings can exist, why not higher-dimensional objects or brains? In a brane world scenario, the strings attached to our brain create the particles and forces we experience. Gravity, however, can seep off our brain and into the extra dimensions, which could explain why gravity is so much weaker than the other fundamental forces. But what about the extra dimensions themselves? They could be compactified, hidden in the fabric of the universe, too small for us to detect. Or they could be large and infinite, with our brain universe floating like a leaf in a multidimensional pond. This theory paints a picture of our universe that is as fascinating as it is complex. It's a reminder of how little we truly know, and how much more there is to discover. So, as we continue our journey into the enigma of hidden dimensions, let's keep our minds open to the endless possibilities that lie beyond the horizon of our current understanding. Could the mysteries of quantum mechanics be linked to these hidden dimensions? This question has perplexed scientists for decades. Quantum mechanics, the branch of physics dealing with the tiniest particles in the universe, is renowned for its strangeness. Particles that can be in multiple places at once, entangled particles affecting each other instantaneously over vast distances. These are just some of the bizarre phenomena that quantum mechanics grapples with. Now imagine if these puzzling aspects of quantum mechanics could be explained by the existence of hidden dimensions. What if particles were not just interacting within our familiar three spatial dimensions and one time dimension, but were also interacting with additional hidden dimensions? This is a tantalizing prospect that could potentially revolutionize our understanding of the universe. Scientists are still trying to unravel this mystery, conducting experiments and developing theories that might uncover evidence of these hidden dimensions. The quantum world, it seems, might hold the keys to unlocking the secrets of these hidden dimensions. Extra dimensions take on an intriguing twist when we consider the multiverse hypothesis. This hypothesis, a favorite among many cosmologists, proposes that our universe, as vast and complex as it is, might just be one of many. Yes, you heard it right. We are talking about a universe of universes, a multiverse. Now you might be wondering, how do hidden dimensions fit into this? Well, some theories suggest that these extra dimensions could be the realms where other universes reside. It's as if our universe is like a sheet of paper in a gigantic multi-dimensional library. Each sheet, each universe has its own laws of physics and its own history. In some of these multiverse models, our familiar three-dimensional world is nothing but a three-dimensional brain floating in a higher dimensional space. It's a mind-bending concept, isn't it? But remember, the universe is under no obligation to make sense to us. In the grand scheme of things, our universe could be just one among an infinite number of universes. As with any groundbreaking theory, the concept of hidden dimensions does not go unchallenged. Many critics argue that theories proposing extra dimensions are merely mathematical fantasies, lacking empirical evidence. Indeed, the idea of hidden dimensions has proven difficult to test scientifically. Some physicists are skeptical, questioning the testability of these theories. They argue that if these extra dimensions are too small or too energetically out of reach, we may never be able to observe them directly. This leads to the criticism that these theories are not falsifiable, a crucial criterion in the philosophy of science. Moreover, critics also point out that theories like string theory, which predict extra dimensions, have yet to make a prediction that differs from standard physics. Until such a prediction is made and confirmed, these theories remain speculative. Despite these challenges, the scientific community remains undeterred. These challenges, far from discouraging, drive scientists to dig deeper and seek more concrete evidence. After all, the pursuit of knowledge often thrives on pushing boundaries and challenging the status quo. As we come to the end of our journey, we realize that we're only at the beginning. The concept of hidden dimensions, once a mere thought experiment, has evolved into a field teeming with potential and promise. It has sparked revolutionary theories such as string theory, the Kaluza-Klein theory, and the concept of brain worlds. It has also ignited a fiery debate among physicists, challenging our understanding of the universe. Yet, the existence of hidden dimensions remains an enigma cloaked in the fabric of the cosmos. It's a mystery that has yet to be unraveled, a puzzle that has yet to be solved. As we delve deeper into the quantum realm, we may uncover clues that bring us closer to the truth. So let's keep exploring, keep questioning, and keep pushing the boundaries of our knowledge. While we may not have all the answers now, the quest for understanding the hidden dimensions of our universe continues. Remember to like, subscribe, and share if you found this video enlightening.